Hello, this is Professor White. Today we will talk about solving rational equations, and let's get started. Okay. Let's say I have an equation where you have fractions in them. Okay, and what do? Get rid of them. You don't like fractions. And I'll show you step-by-step operations to do that. The first thing you do when you see fractions, put brackets around the left and the right side of your equation. Then you look at your denominators, all the denominators involved, and find the lowest common multiple or lowest common denominator of all the denominators involved. In this case, 2, 3. Lowest common denominator is 6. What you do, you put 6 on the left and 6 on the right and multiply. Then you start foiling. What is 6 times x over 2? Here's a hint. Divide before you multiply. It makes it a little easier. 6 divided by 2, that's 3 times x. So you have 3x. And there's nothing at the bottom, so 6 times 3, that is 18. On the right-hand side, you do the same thing. 6 divided by 3, that's 2 times x. And there's nothing in the denominator, so you go 6 times 5, that's 30. Now, you have a beautiful equation without fractions. Take out 2x. You have x plus 18 equals 30. Take out 18. You're going to have x on the left, 30 minus 18, that's 12. You can always check your equation to see if you did it right. How about I have something that has x's in the denominator? The procedure is the same. Find the lowest common denominator of all fractions involved. Here you have x minus 1, x plus 1. So lowest common denominator is simply x minus 1 times x plus 1. Then what do? You put your brackets on the left, put the brackets on the right, and write the LCD on the right and the left. Now what you're going to do, you're going to FOIL. The first one, I'm going to write on the side so you see. You have x minus 1, x plus 1, 2, x minus 1. The beauty of it, the fraction will disappear. You're going to end up with 2 and x, FOIL that in, plus 2. Do you see it? Now I'm going to do this foiling. Now the x minus 1's disappeared. What is x minus 1, x plus 1 times 3? X minus 1, x plus 1 times 3. What is that? This one is x squared minus 1. So that's 3x squared minus 3. Guess what I have? When I FOIL that, I will end up with 3x squared minus 3. That's the left-hand side. Let's deal with the right-hand side. Go to the side and do all these things. So I'm going to go and do the right-hand side right here. Let's make room here. Okay. Now I'm going to FOIL that. I have 3 x minus 1, x plus 1 over x plus 1. Guess what? The x plus 1's will go. You're going to end up with 3x minus 3. So that's the very first thing. 3x minus 3. Now, the second foiling is x minus 1, x plus 1. And there's a 1. So that is x squared minus 1. And you look at the whole problem now. And guess what? There are a couple of things you can do. Let's see. 3x minus 3 plus x squared minus 1. And you have 3x squared minus x squared, so that's going to give you 2x squared. You have 2x minus 3x, that's negative x. You have negative 4 on this, and then you have a negative 1 in here. Negative 4, negative 1, 4, so that's going to become positive 3. And guess what? I moved everything to the left, and that has to be 0. Okay, I'm supposed to solve this. So this one has this, and I try to factor this out. 2x, then 1, 2, 3. I try and try it. I cannot do it. Guess what? This turns out to be prime. That means I have no solution. But I tried out. I really tried, and I could not find anything that works out. Here you go. All right. Let's do another one. This looks like a proportion, doesn't it? Let's find the lowest common denominator. It's going to be the multiplication of these two. What do I do? Remember, put your brackets. Multiply the left and the right by the lowest common denominator. Okay, let's try to do this a little faster. X minus 1s will go. You're going to have a 2 and an x plus 1. Now, in this case, x plus 1s will go. You're going to have a 5 and an x minus 1. Now, let's work these in. 2x plus 2 equals 5x minus 5. Very good. Now, let's move that 2x here. Let's move that negative 5 over here. Then I divide both sides by 3. I'll have x equals 7/3. Now remember the previous example? I had no solution, but this one, I just ended up with one solution. Now, when you do this, when you find a solution to rational expressions, always check. In other words, what am I going to always check? Make sure that that number doesn't make your denominator 0. If that's the case, that's not a solution anymore, because when you put it in there, it will blow up. Remember, you don't want your denominators to be 0. Always check to see if your denominator is 0. If it is not 0, you're all set. But if it is 0, that solution is not a solution. Let's try to do this one. This one is x minus 4, so I'll just explain what happens. Lowest common denominator, since they are the same, it's simply x minus 4. What do I always do? Do my thing. I put x minus 4 here, x minus 4 here. Now let's do it fast. These two will go. You're going to end up with 2x minus 3. These two will go. You're going to end up with 5. Now let's try to solve for x. Move the 3 over. 2x equals 8. Divide both sides by 2. X equals 4. It looks like I found one solution, but guess what? It isn't. Because when I take that 4 and put it in here, this makes the denominator 0. So x cannot be 4. This is what we call an extraneous solution. X equals 4 is an extraneous, I think I'm spelling this right, solution. So in other words, a solution that doesn't count. The answer is no solution in this problem. Or you can just say x equals 4 is an extraneous solution, but no solution. There's no solution. You cannot make these two things work. So remember that. Let's do one that is a little bit more sophisticated. And that's the last one I'm going to do. All right. Before you do something that is kind of hard like this, make sure that you factor out all the denominators. Let's look at n squared plus n minus 6. What is that one? That one is going to be n plus 3, n minus 2. Does that work? This one will give you negative 6, 3 minus 2, 1. Oh, okay, good. Now, it looks like this one has n plus 3 and n minus 2 in it, and this one's n plus 3 and minus 2. So these two can go into that. So my lowest common multiple, or lowest common denominator, is simply n plus 3 and minus 2. Remember what I used to do? Put brackets, put brackets, put brackets, put brackets. Now I'm going to put this n plus 3 and minus 2 on the right, and plus 3 and minus 2 on the left. Okay, now what I'm going to do, I'm going to start scratching them off. This one happens to be this whole thing. So in other words, when I FOIL it in, these two will go. So you're going to end up with 2n squared minus 15 on the left. When you do the right-hand side, when you FOIL this one with this, guess what? This n plus 3 and n plus 3 will go. You're going to end up with n minus 1 here, and this n minus 2 here. Then you're going to have a plus. Now I'm going to FOIL this one. Watch, this n minus 2's will go. You're going to end up with n minus 3 here, and then n plus 3 here. But what's the beauty of it is that it does not have any fractions. Now all I have to do is just kind of clean this up. On the left I have 2n squared minus 15. On the right I have n squared. This one is n minus, so that's negative n. 1 minus 2, that's negative 2. This one is n minus 3, n plus 3. When I FOIL, I get n squared minus 9. You can do the FOILing a little bit slower if you want. So let's look at it. I have 2n squared minus 15 on the left. I have n squared, so that's 2n squared again. Negative n, there's nothing else, negative n. Negative 2, negative 9, so then negative 11. Guess what? These two can go. So what do you have? I can add 11 here. You're going to have a negative n equals negative 15 plus 11, so that's negative 4. Divide both sides by negative 1. You're going to end up with n equals 4. Am I done? I don't know. You have to check. Does 4 make this 0 or any of these guys 0? I go in there. The factors are 3 and 2 and n plus 3 and minus 2. No, it doesn't make either one 0. No, no. Guess what? This is the only solution I have. This is actually one solution. So it is one unique solution at this point.